Halo, selamat sore, Profesor Dr. Furgianto. Nama saya Roberto Belo. Asal saya dari Timor Leste. Pada hari ini saya akan presentasi tugas individual assignment untuk mata kuliah Advanced System Simulation and Modeling dengan paper title paper yaitu Warehouse Digital Twin Simulation Modeling and Analysis Techniques. Paper ini ambil dari Winter Simulation Conference, researcher dari Roster Institute of Technology USA. Tapi mohon maaf sebelumnya, saya akan presentasi ini saya akan membawakan dengan bahasa Inggris. Berhubung bahasa Indonesia saya kurang baik. Well, the topic of the presentation today, there are 6 topics. So the one is introduction, the second one is warehouse system, then the third one is warehouse digital twin framework, and the fourth one is digital twin modeling analysis and decision making, and the fifth is challenging the warehouse digital twin implementation, and the last one is conclusion. For the introduction, so as a component of the industry 401, digital simulation have a potential the material handling of the supply chain industry. To address this, companies are beginning to embrace Industry 4.0, which focuses on the increasing automation through the application of the Internet of the Thinking, sensor, advanced communication system, digital twins, to achieve the smart for the factory. However, the digital twins has a technology can make a significant impact for advanced smart warehouse operation and can be used as a decision making to minimize the productivity, efficiency, and then safety. The concept of this digital twin was introduced by Grievous 2014 and defined as a virtual representation and physical product which with advancement in technology so can be provided as a loop system for product management from time of manufacturing to the end of the its life cycle. Okay, this is the second topic about the warehouse system. So modern warehouses are complex systems with sophisticated equipment, tracking control, and scheduling system. In addition, warehouses are multifunctional with a range of the supply chains related to support activity, including shipping, receiving, storage, and retrieval, picking, kitting, packing, palletizing, labeling, inventory management, the vehicle maintenance, and then vehicle changing, and etc. Furthermore, material handling is in the warehouse may be accomplished through one of the combination of the alternative such manual operate forklift, the automatic gates vehicle, AGV, conveyor people, autonomous mobile robots, AMR, drone, and etc. This is the warehouse digital twin framework. The goal of the digital twin simulation is to provide it continual analysis and decision making, support to enable control and management of the warehouse system, resulting in the operational efficiency. So a conceptual warehouse digital twin framework, as you can show in the figure, warehouse data and control system are stored about the warehouse system, and then system and the supply chains. Although the system um, can vary from the company to company. Some typically system including uh, enterprise management system, EMS, or an enterprise resource planning, ARP. This is the system for tracking assets and the operational information. So, and also the warehouse management system, WMS, for tracking and then managing the warehouse operation. And also the real time location system, this is RTLS. The digital twin of the warehouse system is a simulation model data that replaces the behavior to a state of the physical warehouse system. In particular, the digital twin can be used conduct a simulation experiment such as simulating the near term of the future the system to forecast the potential issues so action can be taken to avoid them. In addition, by capturing this history of the system, the digital twin can be used to analyze how and why the various situations occur. The digital twin of the warehouse can be used for support of the both line and a line decision such as resource planning and dispatching. Furthermore, IA or artificially intelligence method can be designed, trained and tested utilizing the digital twin model and then used to the operation to the physical system. As a digital twin is integrated with the physical system, real-time system information is transferred between the physical system and data control system. As the analysis takes place in the digital twin simulation system, decision and adjustment are transferred back to the physical system. So the warehouse data and the warehouse data and the control system are updated. The digital twin modeling for analysis to decision making. There are three components. The first one is a dynamic and kinetic model in the digital twin. For example, one may be interested in evaluating the capabilities and performance of the alternative types of autonomous mobile robot. So this is under various warehouse conditions. For those types of these decision program, such as ROS or ROS, a common robot operation system language, sometimes they call it like AMR. This is of the robot operating system. Can be used in the conjunction with the GARP. GARP is a visualization or animation tools to develop a dynamic simulation or visualization of the kinetic movement of the IMR as well as the IMR sensor reading such a leader or the other sensor. You can show in the figure 2 is an imaging capture using ROS or robot automatic system and Gabriel dispatching to the kinetic models of the fork track in the warehouse. Also where is a single channel leader. This is a single channel leader is being used is an aid in the navigation. So you compare in the figure 3, you can see in the figure 3 So there are the 3D point cloud data produced by the 16-channel leader mount on the 4-track wire can be used for the navigation and then warehouse mapping. Those types of the models can provide a great insight into the movement and control of the material handling equipment in the warehouse. However, to demonstrate the implementation of the kinetic model of the 4-track, we construct the simple warehouse simulation model in the MATLAB. This slide is a continual of the dynamic and the kinetic models in the digital twin. As you can see, the figure showing an example a path plan generated to the autonomous 4-track to its destination to compare with the actual path taken by the 4-track consideration, the kinematics and sensing capability of the vehicle done using the vector field histogram method. This is the literature from the Koren is about Koren et al. Is 1991, and this is depend on the data obtained from the onboard lidar sensor. The pure proceed controller is used controlling the wheel based on the planning mentioned. This slide is the second of the component of the digital modeling for analysis decision making. So this is the warehouse design planning. So warehouse design planning design are critically to the warehouse operation success. In this case, a company can utilize a warehouse digital twin simulation to analyze the alternative warehouse design and compare them with the current situation, configuration, and operation performance. In particular, the simulation-based methodology is used to determine the optimized mix of the rack or bulk layout of the warehouse layout. You can see there, and consideration inventory quantities and turnover rate. So the model is a design to evaluate system configuration, including the number of the racks and the storage location. So the number of the bulks or lengths or the length depth to the velocity mapping of the product based on the demand. Okay, this slide is the third component. This is artificial intelligence and real-time decision. The task assignment of the path planning or TAPP. This is the assignment task assignment of the path planning. Problem is a operator decision problem that must be addressed 100 or the 1000 of time per day. Overview of the methodology is in this figure. So the figure. So the methodology is instant to enable real time dispatching for the available AMR. This is the robot system. Particular when an AMR become available in the physical warehouse, a dispatch request it sent to the digital twin of the warehouse system, along with the warehouse state information, including the task assignment and the paths plan for another activity AMRs in the system, and depending tracks list with the associated pickup and drop off location data. To implement it in this approach of the TAPP problem, the digital twin is type of the agent-based simulation model where the warehouse layout is represented by the gear wheels indicated rack storage allocation, ageless MR, IMR allocation, and etc. An example of the geared layout is this. So in this, a deep queue network is trained to simulate data and quick find the semi-optional solution to the TAPP problem. So the digital twin send the EPP tapped or the EPP decision back to the physical warehouse to be executed by the AMR. Okay, this topic or this slide about the challenge in a warehouse digital twin implementation and then the conclusion. Some of the biggest challenges center around the interoperability of the exchange data and the information between the physical warehouse system and then digital twin. The second challenge is filtering data so the digital twin can be used to simulate the warehouse system for the problem at the hand. So a strategic decision planning decision and then operational decision require different level the system to abstraction or does different level to type of data. A methodology is needed to align the data required with the data available data. So these are two of major challenge and that if overcome will enable to the border with the digital twin in the warehouse. The conclusion is overall we conducted the digital twin have a significant impact the efficiency and productivity of the warehouse system and then supply chains. Okay, well, this is the my presentation today. So thank you very much for your attention. Bye.